plastic and cement stabilized red soil. Taking the method we did, taking some of quartered red cell and mixing it with various percentages of prepared shredded plastic. The tests done were compaction, Atterback, and CBR tests. The results are the output Atterback greens, compaction, and CBR graph. Those are the laboratory tests. My colleague, Peter. 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 Hello, Peter.
He is not audible. Can you continue?
Okay. Those are the laboratory tests that we did for each sample. As I've explained earlier, the lenser, the mixture of lenser and cement, then the mixture of lenser and shredded plastics. The outcomes were as follows, as you can see. Those are the results we got after we did the results, after we did our tests. We were taking we did a test using 1% of cement, 1%, 2% of cement, 3% of cement, and 4% of each. Then after doing with cement, we added the shredded plastics, of which in each portion we did cement, 1%. Then after those tests, we added now shredded plastics, 1% on each, the other one 2%, 3%, and 4%. As we were observing the compaction, the CBR and Atterback limits.
Okay, time's up. Wind up.
Yeah, can you go to conclusion? Our results and discussion on the test results were as follows. Based on specific objectives to characterize the untreated red soil, plasticity and Atterback limits. Limit at 32% and plasticity index as 28%. Mechanical properties. The maximum dry density was recorded at 1150 kilograms per meter square cubed with an optimum moisture content of 32%. The California CBR test was conducted for untreated red soil and the control of it, it was a 4-day soak. The high liquid limit and plasticity index indicates that untreated red soil is highly plastic and may be prone to shrink soil behavior. This makes it less suitable for construction without stabilization. Low mechanical strength. The low maximum dry density and high optimum moisture content suggest poor load-bearing capacity, necessitating stabilization for construction use. Specific objection number 2, to assess the engineering properties of cement stabilized red soil. This is now where we added the cement. Cement stabilization effect in introduction of cement improved the MDD to 598 kilograms per meter cubed and reduced the optimum moisture content to 12%, indicating an increase in soil strength and reduction in plasticity. Reduction in swelling. Cement stabilization significantly reduced swelling potential, enhancing soil stability for construction purposes. Improved strength and stability. Cement stabilization significantly improved strength and stability. Improved strength, cement stabilization significantly increased more MDD and reduced MOMC, while enhances the soil's road bearing capacity.
Okay, wind up, time's up. That's 13 minutes. Yeah. Wind up.
Okay. The results now from our test. Let me go to conclusion based on specific objectives. Our characterization of untreated land soil. Plastic high plasticity with liquid limit at 60%, plastic PR at 32 and PI at 28%. Mechanical properties, low MDD on 1150 kg per meter cubed and high OMC of 32, indicating poor structural stability. That was now for the untreated land soil. For properties for cement stabilized land soil, there was strength increase. MDD improved to 2598 kg per meter cubed and OMC decreased to 12%, indicating enhanced compaction and stability. Swelling reduction. Cement stabilization effectively reduced swelling, making the soil more reliable for construction use. Effect now, adding shredded plastic to cement stabilized land soil. 1% plastic addition, decrease in liquid limit to 59%, MDD at 2506 kg per meter cubed and reduction in soil to 1.5%. For 2 and 3% plastic addition, liquid limit decreased to 55 and 54 respectively, with the consistent OMC around 34, and the soil reduction further to 1.37% and 1.3%. 4% plastic addition, notable, liquid limit decreased to 41%, highest MDD at 2784 kg per meter cubed, but a slight soil increase to 1.7%. Now, from our test, our conclusion was based on specific recommendations. Sorry, before we go to conclusion. We recommended soil stabilization, use of cement stabilization for untreated land soil to improve strength and reduce swelling potential, particularly in areas prone to moisture fluctuations. Optimal plastic content.
Okay, the rest you'll see in your thesis. We can't continue beyond that. That's too much time. The rest you're going to see in your thesis. Yes, so you just have to stop it there.
We have bar chart presentation. Yes.
Okay, we have to have questions, to have sessions for asking questions, because you're finished all the time, even for asking questions. That's the kind of why you need to practice these presentations before coming to the stage. Okay, I don't know how many of my colleagues are in, but we need to start asking questions here. Yeah. Yes, I can hear.
I'm just confused. Don't know what actually. I can see their comment, their discussion, their There are conclusions, and then there are again conclusions.